Just give me 1 minute. Okay. For one batch, we need to discuss these commands, 4 commands: pull, fetch, push, and clone. Sorry, only 2 commands: pull and fetch. For other one, we need to start with branching. Okay, I'll finish these 2 commands, and people who have completed branching concept, if you want to listen again, you can stay back. Otherwise, you can quit. Okay. So let me finish this so that you can decide whether you want to quit or you want to take those classes. After that,
Nageshwara, today you are going to teach this skipped pending class, right?
this is pending class only.
Okay.
Nagesh, yesterday was not there. So yesterday you completed Maven, right?
Yeah. Yes, Nadir.
Okay. So you are gonna tell now you're gonna start Git which is pending.
Correct.
Oh, okay, great. So let's start. Thanks.
Yeah.
I guess for our batch we need to start from branching.
Branching. For other batch, rebase is complete, right? Feb
Yes,
batch.
it's completed. Rebus completed. Remaining pull and fetch is there.
Only 2 commands are pending. Okay, I'll cover these 2 commands, and then you can decide, okay, whether you want to stay or not. So for other batch, I have to complete branching and merging, 2 classes for that. Okay. Okay. See this. I have asked a team to upload the videos. Okay, Maven videos. Probably they'll upload tonight itself.
Thanks, Nagesh. Yeah.
No problem. So this is the pending Git session. If you remember, so this is our remote repository, correct? This is our remote repository. And if you want to work with Git, we first clone the code, right? So when you clone, we get .git here, and then source area. Okay. Say for example, this stays and then .git, that is local repository. And assume that you have some code here. Say for example, you cloned the repository at 9 a.m. 9 a.m. say for example, right? And it's not only you, right? A lot of other people are also working in this repository. Say there is another user also working on the same repository. This user also clones the repository. You both clone the repository at 9 a.m. say for example. Okay. And similarly, a lot of other users are committing the code to the remote repository. That means pushing the code to the remote repository. So assume that this user committed some changes to the remote repository, and you want to take these changes. How do you take the changes? Question, right? One, you can again clone it. You can remove this particular, you can remove or just keep it, and you can clone the repository again. If you clone the repository newly, what will happen in some other directory, for example, you'll get the latest code. You get the latest, right? So this is one way, but you are again cloning the repository from scratch. That is not required. It will take more time for you to clone the repository. So you already have some code, right? Which you cloned at 9 a.m. And if you want to take the latest, say for example, you have 10 files. You have 10 files. If you want to take those 10 files, you have two options. One, you can run git pull command. Git pull. And the other one, there is one more command called git fetch. Fetch. You can either run git pull command or git fetch command. What is the difference? Question, right? If you run git pull command, git will show you all 10 files. It will compare, okay, what you have in your workspace, right, and what is extra in the remote repository, and it will compare and then it will bring the latest files. That means 10 files you can see directly here in the source area. That's how you update your workspace. That's how you keep your workspace synced with the remote repository. Clear with that? Okay, now fetch. When we use fetch, we want to see what files are going to come. You understand, right? Assume that you are working on something. You have some pending changes, right? You are very careful before you take others code, because you are in the middle of something, and then sometimes if you modified login.java, right? Say for example, other person also has changes in login.java. You have not completed your development and then you have not tested it, right? Sometimes what happens if you take others changes. So if you take pull, for example, what will happen? These changes will be merged with your changes, and that may create a lot of confusion, because you are in the middle of something, you have not tested your code, you have not say completed your development, and if you take the others changes, what will happen to me, right? That may interfere with your changes, right? So it creates a lot of confusion. In that case, you may not want to take others changes. So if you are okay, run git pull command. It will bring the changes. It will merge other changes with your changes. Okay. But sometimes, as I said, you are not ready to take other changes, or you want to check what files are going to come. If you want to check, run git fetch command. You know what git fetch command does? Git pull will directly pull the changes, right? Git fetch will pull the changes, yes. It will pull the changes, but it will not show you in the source area. No, you have 10 files, right? 10 files it will not show you here. No. But it will pull the changes and then it will pull the changes and then it will save the changes in some temporary directory somewhere in your .git. Temp directory is what we say. Understand that? Fetch command will pull the changes, but it will not show you in the source area. That means you are safe, right? You don't want to mix other changes with your changes. And then you can, whenever you want, you can get. So two examples here. One, before you pull the changes, if you want to know what files are going to come, run git fetch command, first thing. Second thing, when you run git fetch command, what will happen? You can see what changes are going to come. It's like a dry run. It's like a dry run. That means sample run. And you can see what files are going to come. And if you're ready, run git merge command. If you run git merge command, it will bring the changes. That means, see, very simple. Fetch plus merge is equal to pull. Simple. Pull will directly bring the changes. Same thing, if you want to do in two steps, run fetch command first. It will bring the changes, but it will not show you the changes in the source area. That means you have not pulled it. But changes are there in your repository, in your local repository somewhere in the temporary directory. And you can also see what files are going to come, how many files are going to come. And then when you're ready, run git merge command. That will show you the changes. That is the difference between pull and fetch. Clear with this? Any questions before I show you these two commands? See this. So just to demonstrate this, I will clone the repository in two places. Okay. Like two new users. So for example, this guy. See this? Let me go to our repository, some repository. Okay. Git clone. https://github.com Nagesh weekend slash ycult72.git some repository. Okay. Okay. No. One second. Assume that I have two users. Okay. Harry, Sally. Two users. I'll clone Harry's repository here, Sally's repository here. Okay, like this. Harry's repository, Harry's clone, and then this is Sally's clone, for example. Go to Harry. Harry wants to work in this repository, so Harry clones the code. Now Sally also is working on the same project. Sally also clones the repository. Okay, both have their own repository. In that, this is in one mission, and then this is in another mission. Now assume that Sally, okay, Harry. Assume that Harry commits some files to the remote repository. Now both have the same code, right? Now Harry is working on something. Let's say I'm just creating some sample file, okay? Terraform.tf, for example, something like that. Git add, git states, git commit -m infra automate. It's a new mission, right? So before we commit, we have to configure the username and email ID, right? Git config. We have discussed this already, right? We have to configure the username, global user.name, my name, and then user.email, email, info@faculty.com. I'm committing git push. Let me generate the token quickly. Every time this is asking. This is how we generate the token, right? Settings. developer settings, classic. Classic. Enabling the paste. Okay. Fine. So there is a new file. The new file is Terraform, right? This is there is a new file here, Terraform. And Harry doesn't have this battle file, right? Assume that likewise you have 10 file changes and Harry wants to update his workspace. So what options Harry has? Two options, right? One, Harry can take two-step approach, that is fetch and merge, or Harry can directly run pull command. Assume that Harry is ready to take the changes. So what command Harry will run? Pull command. See this? I'm going to Harry now. Sorry, Sally, okay. This is Harry, Sally. Now let's go to Sally. This Sally doesn't have the Terraform, correct? Now, Sally is ready to take other changes. So Sally will just run pull command. Just straightforward. Ls, you got the file. So it will just compare your workspace. Workspace means this, whatever you have cloned. It will compare and then it will bring the missing files. Simple, right? Let's see how fetch works. Again, as usual, Harry commits some other files. There are some changes. Say Jenkins, okay? Jenkins. Search Jenkins file, something like that. Git add Jenkins file. Git commit -m. Something like this. Git push. Now there is a new file in the remote repository. Now assume that Sally, right, Sally wants to be very careful, right, before she pulls the changes. She doesn't want to unnecessarily, she doesn't want to pull unnecessary changes. She's not ready to take the changes. So what command Sally will run? Fetch command. Or in other words, Sally wants to see what files are going to come. 1 second, I have one command. I used to demonstrate fetch command in a different way earlier. Later I found, that was not a good example. So just change it. So I have that in the notes. See this? If you want to know what changes are going to be pulled from remote repository before you update your local copy. Okay, so this is the thing. So you have to say git fetch origin. So you will see, output like this. Let me run this command. What's that command? Git fetch origin. Origin means remote repository. It's like this, okay? That's a syntax. You have to remember that. It's like fetch the changes from remote repository. Origin means remote repository. Remember this way. So this is originated from the remote repository, right? Correct. So in run fetch command now, what will happen? It will bring the changes here. Okay. Let's see. Fetch is done. Harry submitted, correct? Sorry. Terraform.txt. Harry submitted terraform.txt. Sorry, very sorry. Harry submitted Jenkins file. Harry. Right? Now we have to go to Sally and then fetch command, correct? I'm going to Sally now. So Sally. So what command Sally will run to see the changes? Git fetch origin, right? Okay, see this. Now it says, I'm bringing the changes between this and what changes till what commits Sally has changes? Git log -n1 latest. Till what commit Sally has the changes. This is the one, right? Sally has the changes till this commit. See, 0 db fbd6. And there is a new commit in the one or more commits. So it says, I am fetching the changes. You have this. You have changes till this commit. I am fetching the changes from this commit to this commit. There may be any number of commits. So I'm committing. I'm bringing everything. And now you want to know what exactly is coming, right? What command we can run? Can somebody tell me?
Git show.
Git show. This is the latest, right? I'll say git show on this. Git show. See, it says Jenkins file is coming and it's a new file. There is no content. One way. Okay. That's how you see what changes are going to come. And you see this? Do we have this Jenkins file here? No, right? It's not shown. As I said, it'll bring the file. It'll store in the temporary directory, right? Now you have the changes in the temporary directory in your local repository. Yes. That's how you know what is going to be fetched. Now, if you want to see what changes are already fetched, possible, right? Today I ran fetch command. And then I, verified. I verified what is, coming from the remote repository. Like this, I verified today. Okay. So when I run git fetch command, since there is an output, I'm able to run git show on this, and then I'm able to know today done. Tomorrow I don't have that git fetch command output. If I have that output, I can run git show and then I can see, right? But I don't have next day. In that case, how do you know what changes are already fetched? Run this command. Git log head origin master. Git log head origin master. Git log head. That's correct, right? Icon. Is it not working? Git log head origin master. As I told you, I changed the approach a bit. That is the reason. Let me run that. Fusion path not in working directory. Use -" to separate paths from revisions like this. Git command revision. Let's see. Correct, right? Git log head origin. Okay. Got it. It is not master, main branch, right? We have main, no? Not master. Earlier it was master, so I'm used to that. Main. See this? This is the one. This is the extra commit which was pulled. Okay. Last time. And then run git show commit. And this same thing. Okay. Summary. Before I pull the changes, I want to know what changes are going to come. So I run git fetch command. You can see, the commit ID, and then you can run git show command on this. Today, done. Again, you're not synced the changes. You're not taken the changes. You're working on something. You already fetched, right? That means you have the changes, correct? So next day, you want to know what changes are already fetched. In that case, run this command. Remember this, okay? Head means the latest. Latest, what you have in your local repository. This is head means latest in your latest commit in your repository. Origin master. Get me the log between the latest, what I have with, compare, what I have latest with the latest in the remote repository, origin main. So it will compare both and then it will give you something like that. That's how you fetch and see the changes. Now I'm ready, say for example, I'm ready to take the changes. What command we can run? Git fetch plus merge is equal to full, right? Now, after running merge, what will happen? You can see the changes here. It will bring the changes from the temporary directory to this. Fetch plus merge is equal to full. Clear with it? That's all simple. See, very rarely we use fetch. Mostly we just directly pull the changes from the remote repository. Clear with this? Okay, that's about this. And now we'll start with the branching. If you want to stay, you can stay. Otherwise, you can quit. So once this pending class is over, then we'll start either Jenkins or Docker.
So not today, right?
Not today. Not today. You can quit. Anybody wants to quit or you want to stay? Let me know if somebody wants to stay. Just say I want to listen again, so that I can change my teaching method a bit.
So I'll stay back. I'm rather new, so even though I've seen the recordings,
Okay, sure.
just see it again. I'm not sure about others who have already attended the class.
Yeah.
If they want to drop out, they can drop off.
Okay, so branching. This is the remote repository, right? So far I used to say, when I explain, I used to say, we push the code to the remote repository. Or I used to say, we store the code in the remote repository, correct? This is your remote repository. Okay. But code don't stay directly in remote repository. No. For example, login.java, right? Login.java won't be directly in the remote repository. No. Instead, inside the repository, we'll be having something called a branch. Think branch as a directory again. Okay, folder inside your repository. What do you call this? Branch. That means, remember this, repository. This is a folder, for example, remote repository is a folder. Inside that remote repository, you have another, remote repository is a folder. Inside the folder, you have another folder. Think that way. So we call this as a branch. We don't call it as a folder. We call it as a branch. And name of this particular branch, name of this particular folder is called as main branch. I've just used main, right? Git fetch head ---- origin /main. This is it. You will understand that fetch command later once I explain the branching concept. Okay, so we have a branch in remote repository and code stays inside the branch. Code stays inside the branch. For example, login.java is here. And when you create a remote repository, Git will automatically create this main branch for you. When you create a remote repository, right, Git will already create a main branch. Okay, a folder inside the repository automatically. That's a default one. And so far, this is how you are working. Okay. So when you clone, what will happen? Tell me. Whatever you have in the remote repository, everything comes here. Right? Both are same. You get exact copy, right? And inside the remote repository, you have main branch. Here also, you'll get the main branch. So this is your local repository, right? Local repository is same as remote repository. Local repository. Okay. So inside the local repository, what is there? Main branch. Main branch. And then you have the code here. If you have 10,000 files in the branch, main branch, here you will get 10,000 files. And then this is the main branch, right? And then it will show you the code from this particular branch here. Simple. The source area. This is your source area. Source area. And here you have login.java or 10,000 files. That's how we are working before. Okay, so very simple. You know how to create the remote repository. I'll show this to you. Okay, so when you create a remote repository, by default, Maven creates, Git creates main branch. Branch is nothing but a folder. When you clone, you get the same thing, right? Here you have 10,000 files sitting inside the branch, right? So 10,000 files come in the source area. You modify, you add it to the stage, you commit. And then when you push, what will happen? Commit goes to main branch in the remote repository. That's how you are working. Let me show this to you. Which repository we were working? Faculty 7.1, right?
72.
7.2 only.
72.
Okay. March batch. We can see that here. Okay, you're right. Okay, so this is our repository, right? Okay. Now, where these files are sitting? Inside a branch, right? 1, 2, 3, 4, 5 files are there. So you have 5 files here. Here you have 5 files, and then you can see 5 files here. That's what is working. See this Git status. What it says? You are on branch main. It says whatever code you see here, that is from the main branch. That is the meaning of first line. This particular code is from main branch. If you want to, there is one more command to see which branch code you have. Run git branch command. If you run git branch, it will show you the branch code that you have currently. Green color main means, okay, I have the code from main branch. Similarly, you can have multiple branches. You can have multiple branches in your remote repository. I want to give you a simple analogy, right? Say, question, right? Why I cannot store the code directly in the remote repository? Why the branch is required again? And so the remote repository, why another folder is required? Why? Say this. I'll give the same example that I explained before. For example, you have some pictures, right? Somebody comes to you and then says, okay, I have money, you have a lot of pictures, give me all these pictures. I'll edit the pictures and give it to you. Do you allow this person to directly modify the pictures, beautify the pictures? No, because your friend is modifying some pictures, means he or she is doing some experiment, correct? And if you don't like the beautification, for example, you will lose the original pictures, right? So you will not allow to directly modify your original copy. This is your original copy, correct? Instead, what you can do, instead of allowing in that original copy, you copy paste this particular folder, copy paste, and then your friend can do anything here. He can modify, she can modify anything here. So that's how we do, correct? So whenever you want to do some experiment, don't modify, don't do experiment in original. If you do the experiment in original, what will happen? The original copy, a stable copy, may become altered, and it's not enough. It may become unstable. So your friend can edit the pictures here, okay, and then probably you test it. Test if the pictures are correct. So if pictures are, if you like the pictures, you can accept them as a original. In software also, same thing happens. We have a original copy of our software code. We have original copy of our software code. This is the one. Okay. Say for example, you have 10,000 files. Some, a lot of files you have. You have 100 developers. These guys are developers. Do you directly allow these developers to modify the code in the original copy? We don't call it as a, okay, original, say for example. Instead of calling original, I'll call it a stable, okay? Stable means working code, or original, whatever. Stable code. If you allow all your 100 developers, right, to modify the code here, they're again modifying the code, right, for bug fixes, feature developments, and so on. Again, they're modifying means they're doing some experiments, right? If you allow all these people, this code will become unstable. Unstable. Here, right? See, you are agent debug, right? You have, today you come and then you modify, you modify 10 lines, days, 4. Again, you come tomorrow, again, you make some changes. That means what? Yesterday, whatever file was there, that was good. The code was good. Today, you have the partial changes. You are now halfway, for example. So that means code is not working. Earlier it was working, since you modified or you did some experiment. See, you are modifying means when you modify, it's not that your changes work always, right? You have to test it, correct? So that is the reason what will happen. We don't directly allow developers to modify the code in this stable copy. Instead, what do? We create a new copy. We create a new copy. we create a new copy. So we create a new copy, same code comes here, 10,000 files, correct? And then we ask developers to modify the code here. They can do anything here because it's a duplicate copy, correct? So this copy, a stable copy, is called as a main branch. What is it? Main branch. Main, this one, this folder, okay? Whatever code you have here, this is always considered as a stable copy. We should not modify the code directly in the main branch. If you modify the code here, what will happen? Tell me. The code will go unstable, right? Instead, what we do, we have the code in the main branch, correct? This folder, we get a duplicate folder. You call this as, for example, I'll call it as dev 1.2.3 branch. You have to give some name, okay? It's a copy, right? Dev 123 branch is copy of main branch. And then our developers modify the code here, so that we work like this, for a month, 2 months, for example, in this branch, okay? And then we test this code. We test this code. Our testing team tests the code. If the code is passing the test cases, testing team will say code is good, and then we will merge the code back to the main branch again. When we merge, what will happen? Tell me. If say 100 files are modified here, 100 files will come in main branch. So what we are doing here, basically very simple. We have one copy of the code. Whenever we want to work for the new release, okay, next release, for example, we create a duplicate copy, we do our experiment here, we test it, and then we merge the code back to the main branch. That's how we make sure that main code is always stable. Main code is always stable, correct? Because you are testing and then bringing the code, correct? So that's how you make sure that main is always stable. Clear with this, the branching concept? So what we do here, we will create another branch, correct? We'll be having another branch here in remote repository. So assume that this is your dev branch. Dev 1.2.3 branch. So this branch is created from main, correct? Main. So whatever code you have here, same thing comes here. If you have 10,000 files here, you get 10,000 files. Both are same. How many copies we have in the remote repository? 2 copies. This is 1 copy, second copy. This copy is stable copy. Here, this is created for your experiment. You can do any modifications here. Okay. Now, who creates this remote repository? DevOps engineer. Sorry, who creates the this particular Dev 123 branch? DevOps engineer. Assume that DevOps engineer creates a new branch, new copy. Then comes Harry, for example, developer. Harry clones the repository. When Harry clones the repository, Harry will get 2 copies, right? Correct? You have 2 copies in the remote repository. Here you will get 2 copies. Dev 1.2.3 branch. So Harry will get another copy here. By default, Git will show you the code from the main branch, but Harry wants to modify the code in Dev 1.2.3 branch, correct? In this copy. So Harry will run a command. For example, Harry runs git checkout dev 1.2.3. If Harry runs git checkout dev 1.2.3 command, what Git will do? Harry will bring the changes from here. It's like you can switch, okay? If you want to see these changes, you can bring the changes from this copy. If you want changes from dev 1.2.3, run git checkout dev 1.2.3, it will show you dev 1.2.3 code here. So in source area, you can either take code from main branch our dev123 branch. So Harry will run a command called git checkout dev123. It will show you dev123 code. Harry will modify, commit. It will go to dev123, and then when Harry pushes, the changes goes to remote dev123. We work like this for a month, for example. Once everything is done, what do? We merge the code from dev123 to the master. And then here you have some extra files, right? We'll bring those changes from dev123 to master. We have created a duplicate copy. We did some changes. We are merging the code back to the main. Remember, no matter how many branches you create, okay, end of the day, your code has to go to main branch. So main is meant to have the complete application code. Okay, you are taking a copy, you are modifying the changes. You have to merge the code back to main once it is tested. So main means main is meant to have stable code. It's meant to have the complete application code. So that is the reason we have branching concept in Git. If you don't need to manage, if you don't need multiple copies of your software code, you don't need branches. You can directly store the code in the repository. You take any version control system, any source code management tool, CVS, SVN, Git, Perforce, TFS, this branch concept is there. So branch means a duplicate copy, correct? So what is a branch? Branch is a copy of master. Branch is not, okay. Remember this, sometimes people call main as master. Earlier it was master. Recently they changed it to main, okay? Now, that means earlier this default branch name was master. Now they started creating this as main now, okay? So you will still see master in a lot of documents and things like that. People also refer sometimes it as master. Master, main, both are same. Okay, so what is a branch? Branch is copy of master. You can also mention like this in your interviews. Branch is nothing but a folder in the repository. Start with this, that's okay. Branch is nothing but a folder in the repository. Branch is copy of main. Main itself is a branch and it's a default branch. When do you create a new branch? Whenever I want to work on new things, new release, for example, right? I go and then create a new branch. What is this dev123? This is the release name. You go to any product or software, there will be versions, right? There will be versions, Android 1.0, 2.0, 3.0, any software you take, there will be versions, right? So what is the meaning of 1.2.3? Okay, before that, I want you to understand how, in real time, teams, plan their new development, new releases. One second, let me get the adapter. One second. Okay, see this, I said, we create a duplicate copy whenever we want to work for the new release, right? Since if you go to Flipkart, this is how they plan the release. They come in con call. For example, dev team is in conference, company chief technology officer, CTO, probably sales team, marketing team, or some teams. Okay. So all these people meet in a meeting, for example, and then they discuss what needs to be developed in next 1 month, a roadmap. CTO comes and says, we want to develop a drone delivery feature. Drone delivery is, is very, it is kind of a buzzword now, right? In e-commerce, quick commerce, basically. So CTO says, we need to implement that technology. For example, salesperson come and say, there is a bug in our system, Flipkart, for example, Flipkart. So when we take orders written, right? And when we verify whether the item is purchased from us or not, sometimes a data, we get some errors. It will not show the item numbers or item price or whatever. There is some issue in the system. We need to fix that. Likewise, they plan what needs to be developed in next 1 or 2 months. Assume that they decides to develop 10 new features like drone delivery, and then 20 bug fixes. 20 bugs. See, if you go to Flipkart, you see thousands of bugs. There is no software in the world without bugs, correct? Can you fix all bugs, thousands of bugs overnight? No, right? So you prioritize, right? The blockers basically. So they decide to, develop 10 new features and then 20 bug fixes. They also decide the timeline. Assume that today is Jan 1st. We have to start working on this, 10 new features and then 20 bug fixes Jan 1st. And then we have to finish the work by March 1st. So this is called as a release timeline. What is it? A release timeline. So they also discuss, they also define a timeline, okay? How long within, in how many days we have to finish this. So we call this as release planning meeting. You can say release plan meeting. Okay. And then they also create something called a calendar. Release calendar. Here, there will be different milestones. For example, Jan 1st, DevOps team to create a new branch. Jan 1st, as soon as the branch is ready, development teams should start their testing. Then testers should complete their testing by say 15th, for example, testing. So there is some timeline basically. So that's the reason in software people sometimes work weekends, day and night, because they have to meet some deadlines, milestones, and all the teams will be working accordingly for this new release. And when you decide, right, to go for a new release, you have to give a name for your release. That's when a release number or release name comes into picture. Assume that it's a 1.2.3 release. What is the release name? 1.2.3 release. They also give a name. See, you get Android updates, right? 1.2.3, 1.2.4. So before you receive the updates, right? They would have they plan like this. No, they also plan what needs to be developed in that particular release. They work like this within given timeline, and they release that Android version to your mobiles. That's how it works. Any software, that's what we do. So what is the release name? 1.2.3 release. What is the meaning of 1, 2, 3 here? first digit always represents that it's a major release. That means if you are releasing a lot of major release means this lot of features you are giving, lot of bug fixes you are giving to your customers. If that is the case, you call that a major release. If it is a major, if you're giving major release, you will increase this number. Second digit says it's a minor release. Assume that you are giving a few features and then few bug fixes to your customers. It's a minor release. So if you are doing minor release, you will increase this number. Assume that you are giving only few bug fixes and then you are releasing a new software. You increment the third digit. So this is called bug fix. This represents that it's a bug fix. Assume that I start, it's my startup company, okay? First time I'm releasing my software to customers. What's the name? Release number can be 100. Then I take 2 months of time. I develop some new features and then few bug fixes. It's a minor release for me. So what do? I increment this number. Second is minor. Again, I take 1 month. This time I'm giving only few bug fixes to my users. I'm not introducing any new features. It's a bug fix release, right? So what do? 1, 1, 1. This is a bug fix release. Now my product is going through a lot of architectural changes. Okay. Introducing artificial intelligence first time in my application. That means it's a major change. So any such things, right? Major things means a lot of features, bug fixes, your product is, there's some massive changes in your software. It's a major release. So what do? 200. That means this number is incremented, means customers know that okay, this is a major release. And they decide whether to purchase your software or whether they want to upgrade or not. So that is the meaning of numbers. Sometimes people will be having, fourth digit also. In that case, they call it as a hard fix or something like that, but it's very rare. See, there is no rule that everybody has to follow a 3-digit release numbers. It depends on the organization. When you join your new company, they will tell you the naming convention they are following for the release. Summary. Flipkart team meets to discuss what needs to be developed in next 2 months. They decides features and bug fixes, and then they also fix the timeline. So no matter what, within that timeline, they have to release the software, and they also create a plan, execution plan. Right? Team has to do this. Development teams, to start the development. Testing team should complete, testing by this date. And then March 1st, any cost, we have to do our new release. So whenever they plan to work on new things, they also give a name for that so that people can aware whether it's a 1.2.3. These 10 features are released part of 1.2.3 or 1.2.4 or 1.2.5, what it is. Why this version number is required for any product or software? What happens if there is no version number? Assume that you have 2 users, correct? There is a software. You release the software today. Both users are using your software. Again, you took 1 year time. This is the first year, say for example. This is second year. You came up with new features. This guy has the first release. When first year, whatever software you have given first year, second year also you have. But this guy is still sitting on the old code. This guy has not updated. This guy has not taken the latest update. This guy has update. This guy has the old software. Now this guy is facing some issue. This guy reports some issue to you, right? How do you know, right, that issue is coming in the latest code or the old code? How do you know? That is the reason we give a number for our softwares. For example, I say 1.2. Say initially, it is, say, for example, 1.0. Both have 1.0, 1.0. Next time you developed something, you called it as 2.0. This guy has 2.0 code now. This guy still has 1.0. So when this guy reports some issue, you ask this guy, which version of the software you have, 1.0. So you know how to fix, because you may be having a different technology here, right? And things like that. You call your car customer care. You say that I have some problem in engine. First thing that they ask is, what version of car you have? 1.0, 2.0, or what it is. Cars have some versions. Because in the latest, right, they may be having, new technology. In the old, they may be having, old technology, right? So if you say the version of your car, then they decide, how to fix that. Then they suggest how to fix that problem. It's that. So whenever we want to work on new things, right? We are planning to work on new things means you modify the code, right? You modify the code. So what do we do? Can we directly modify 1.2.3 changes here in the main? No, right? No. You decided to develop 10 new features and then 20 bug fixes, right? Correct. Can you make these changes here directly? No. If you make the changes in main, what will happen? Tell me. This copy will go unstable, correct? This copy will go unstable. That is the reason. What do? We don't modify the code. Instead, what do? We take a duplicate copy of the main branch. If you have 10,000 files here, you'll get 10,000 files. And I'm giving a name for this branch now. What is the branch name? This is main branch, and this is dev 1.2.3 branch. That means this particular copy is created to develop 1.2.3 release. So we have 1.2.3 release code. That means there's 10 bug fixes, and then features code goes in 1, 2, 3 branch. Now you do your experiment for 2 months. You have 2 months, right? You modify whatever you want here, right? For 2 months. And one day, once development is done, what do? We test this particular code. And if everything is fine, then we merge these changes back to the master. So main gets the tested code always. That's how you make sure that main branch always contains a stable code. Very simple. You take a duplicate copy, do your 1.2.3 release work. Once it is done, merge the code back to main. That is master. But don't directly modify the code in main branch. If you modify the code in main branch, this will go unstable. Now you may be having one more question, right? Maybe thinking about this, why I should have the stable copy? That's again another question, right? Why I should have a stable copy? Can somebody tell me? People who completed the branching concept. Why we need to have stable copy? Why we need to have at least one stable copy?
Because already website or something is already running, right? So if something is happening here, that will go unstable or that will go down.
Yeah.
Or if something we are changing directly to the main and we don't have any backup, we don't know what exactly happened and everything goes unstable. So that's why we should not we should have one at least main branch.
Correct. Yeah, that's also correct. See this. I'll give you one more example. So in software, we perform different levels of testing. We know that, right? Development, sorry, was it manual testing, automation testing, system integration testing, performance testing, regression testing, and so on, correct? Say, for example, this is how we usually test the software, Flipkart, right? This is the Flipkart. You first test only the login module. Then you test search functionality. That means module-wise testing you're doing. Okay. You test login, search, and then cart functionality, and then payment gateway functionality. So we call that as module level testing, whatever. And then assume that you want to do performance testing. Performance testing. Okay. If you want to do performance testing, your software, the complete system should be working fine, correct? If individual components, if any of individual component, if any of the individual components don't work, then you cannot do performance testing, correct? Simple analogy, take a car example. Okay. You have wheels, okay, car body, for example, right? You have engine, right? Whatever. Say, for example, you want to test the performance of your car. You want to test the performance of your car. If you want to test the performance of your car, the wheel should be working fine, right? Engine should be working fine, and all all individual components should be working fine, right? If something is not, if wheels are not working, can you do the performance testing? I want to take my car to muddy roads, hill stations, and then do the performance. If wheels are not working, if you have some problem in engine, you cannot do the performance testing. Same thing in software. Say performance means you put some load on the entire system, and then you see the performance, how it is behaving, right? So if you want to do performance testing, you need to have a stable code. You need to have a stable code. For example, right? This is a stable copy, say, for example, stable code, right? Everything is working fine. Login module, payment gateway, all software, modules code is working fine. And then that's the reason, what do? I go and then I can do performance testing on this code. That means for performance testing, right? I take the code from which branch? Main branch. In other words, I can say we do performance testing on the main branch because the code is stable. I cannot do performance testing on this copy. Why? People are modifying, right, for new release. It's an experimental copy, right? If you run your performance testing, performance tests here, things will not go because it's a most unstable, copy, because people are actively working on something new. It has the partial changes. That is the reason, right? If you take any software product, we always make sure that there is at least one copy so that we can do performance testing. And you need it actually. For example, there is a critical bug in your production, right? If everybody is modifying the code, assume that this is not there. If everybody is modifying the code here, and then you have the good code here, the good code today, tomorrow there is some issue here. So you have, assume that you have only one copy and you modify some files here to fix that issue. Can you release the code from this copy to the production? No, right? Because along with this, you have a lot of other things, and these things are not ready. Right? These things are not ready to go to the production. That's what happens if you modify, everything in one copy. We don't do that. If I have a stable copy, what you can do? For example, there is a, issue in real-time production. So stable code, correct? You just modify the files, fix the code, and then you can release this copy because this is stable, right? We just added 10 new files, for example, then you are giving it to your production. So having stable copy is very important. That is the reason we have this branching concept. Very simple. Whenever you want to work on new release, whenever you want to do some experiments, don't modify anything in main. Instead, take a copy, duplicate copy, do whatever you want, test it, move it back to the main. So that's the reason we have branches exist in any source code management tools. So when you create a remote repository, by default, Git creates this main branch. Whenever we want to work for the new release, For example, day 1 to 3 release meeting is done, planning is done. They send one email to us, DevOps team, saying, hello, DevOps team, please create a new branch for us. Everybody know that we have to do our new work in a separate branch. So what do? We create a new branch. I'll show you branch creation commands later. And then developers, they clone the code. They get 2 copies, main, day 1 to 3. They take the code from day 1 to 3 to the source area, and then they modify the code here, and then they commit. It will go to, when they push, it will go to the same remote repository. We work like this for 2 months. It's a 2 months release, right? Jan 1st to March. So once everything is done, we test this particular code. One day we will merge, we'll bring the code from dev 1 to 3 to the main branch. So main gets a tested code, stable code of this. That's how we do our work. So creating branches is our responsibility, and merging the code from one branch to another branch. We have to bring the code from this branch to this branch, right? So that's also our responsibility. So these are the 2 things that only DevOps needs to do in real time. Okay. So otherwise, whatever comments we discussed before today's class, those comments are used by everybody, by developers, you, me, whoever is working. If anybody is working on the project, they use all those Git commands in their daily life. But branching and merging is something which we only manage. Clear what is a branch, when we create a new branch, and how users work on different branches, how companies plan their new releases, terminologies, release meeting, release calendar, release timeline, features, bug fixes, branch naming convention. Try to remember that terminology. You will hear all this. See, sometimes you may see different things also. Sometimes people got the release calendar, or any other names you heard for this release calendar? Not getting that. Okay, they call it as release playbook. Earlier, I don't know. Earlier, you would have heard this, right? So before you go and play a game, people used to have the strategy, right? People used to note down everything in a book, playbook, how to play the game, strategies and things like that, right? So the same terminology it is here. So release playbook or release calendar, or it can be anything. So when you join in new project, you will hear, okay? You will understand the terminology. Somebody will explain those things to you. That's about theory. What is branch, why and when we create a new branch. And in tomorrow's class, I'll explain different branching strategies. There is something called branching strategies or models. So once I explain that, then I will give you the commands using which you can create the branches. And then we'll talk about merging. Clear with the concept? Any questions for me today? March batch, any questions?
No, Nagesh.
Okay. Okay, then that's all. Thank you. Good night.
Yeah, good night all. Bye.
Bye.
Yeah, kindly update the yesterday's classes.
I'll again follow up with Aisha right away.
Okay,
Thank you. And once it is done, I'll ask her to update in the group.
Thank you so much.
Thank you.